relative velocity. So in the relative velocity, how do you express? For example, v is nothing but velocity vector of a and b given. There is nothing but velocity. What is the meaning of this? Velocity of a with respect to b, which is nothing but va bar minus vb bar. That is nothing but va bar plus of minus vb bar. This is called as relative velocity of a with respect to b. Now in the given case, we have some examples how to find out relative velocity. Let us see. In the example 1, let us imagine that two objects are moving in the same direction. First one is VA and second one is VB. Then the relative velocity VAB bar is equal to simply conveyed down as modulus of VA minus modulus of VB. By using this concept, we can write down relative velocity of A with respect to B. In the example number 2, suppose if first object is moving in this direction, second object is moving in this direction, opposite direction, then the relative velocity VAB bar is equal to modulus of VA plus modulus of VB we have to take. Why we are taking direct addition here? Minus of minus becomes what? Plus, because look at here, VB is minus. So here in the given problem, VA minus of VB actually going in the forward direction is positive, but it is going in reverse direction. Therefore, one more minus will write down here. So minus of minus will give you plus opposite direction. And example number 3. In the example number 3, for example, if two objects are simultaneously moving in the perpendicular direction, this is VA and this is VB, then the relative velocity is given by VAB is equal to root of VA square plus VB square. We can take it like this. Suppose in the next example, we have example number 4. Suppose this is the first object A and this is second object B. So VA and as well as VB angle theta degrees with respect to each other. Then the relative velocity is given by VAB magnitude is given by root of VA square plus VB square minus 2 VA VB cos theta. You have to apply here Palangamla vectors. That's it. Next example. Example number 5. Let us take. In this example, suppose here is something like a flat ground, and here is the some device or something like a vehicle which contains longer cannon. Okay, it can eject bullet with a speed of VB from it, and vehicle is moving with a speed of VA. This is called the target vehicle, which is moving with a speed of VT. Okay, on the road like this. Then, in this particular case, how do you find out the relative velocity? In this particular condition, bullet already moving with the speed VB, addition to that of VA is there. Therefore, in this case, V relative is given by VA plus VB, vehicle A plus velocity of the bullet, both are in the same direction. You have to add here. Why? Because the addition to that of bullet, this one also pushing it. As a result, we got maximum minus target vehicle is VT bar. So by using this particular formula, okay, you can calculate the value of magnitude of relative velocity of bullet with respect to this particular person. Next, example number 6. Suppose this is uniform circular motion. Now at this case, the two instantaneous tangents, we have the tangents having the angle of the tangents will be theta degrees, so that they would have made angle theta at the center. Question is that what is the change in velocity here in this case? Change in velocity means a relative velocity only they are asking. Under such case, you have to apply the above condition. VA square plus VB square minus 2 VA VB into cos theta we have to take, which is given as V square plus. So in this case, we have V square plus V square minus 2V square cos theta. So Upon solving this, we get 2v sine theta by 2, nothing but the right answer for this particular condition. And what are the important things you have to remember in this case? The second component, that means in the calculation of VAB bar, VA plus of minus VB bar. So to the actual, you have to take a reverse. Example, this is the value of VA, this is the value of VB. These are the given conditions. Then in calculation of relative, this is VA bar and this one is minus VB bar. This will become the resultant of VA bar minus VB. This is the resultant direction. So in the calculation of relative, we have to take care the opposite of second one you have to take and then you have to proceed. Third important thing is that in the applying of reverse conditions, natural effects cannot be reversed back. That is important thing. We will see what is the natural effect and how that will influence the system in the forthcoming examples. Next one is relative acceleration. Relative acceleration. Let us see this particular case. This will help you a lot in calculation of lift problem or free body diagram problems. Anyways, if the accelerations are in the same direction for the two given vehicles A1 and A2 are the same direction, then the relative acceleration A12 is equal to simply write down as A1 minus A2. In the second example, if the two vehicles are going in opposite direction A1 and as well as A2, then the relative velocity acceleration is given by A1 plus A2. Simply I am just using magnitudes, no need of vectors here. And in the gravity direction, suppose object is moving in upward direction and gravity acts in the downward direction, then the net acceleration is given by because of opposite. That's why I write down as G plus A. And in the fourth example, if object is falling free and with an acceleration of A in the gravity field, then the net acceleration is given by G minus A. Suppose in the gravity field, object is moving perpendicularly with acceleration A, then the net acceleration is given by root of G square plus A square because theta is equal to here 90 degrees. Now, next one, relative angular velocity. Next concept. Relative angular velocity. Let us take it. In the relative angular velocity, suppose if the first object is rotating with a clockwise having angular velocity omega 1, second object also rotating in the same case omega 1 and omega 2 in the same direction, then the relative angular velocity is omega 1 difference omega 2. Under such a case, you can write down as 2 pi by relative time period of t12 is a 2 pi by t1 difference 2 pi by t2. Here, the formula for angular velocity omega is equal to 2 pi by t is a standard formula. Okay, I am using that concept. And frequency f12 is equal to f1 difference f2 you have to write down. Omega is equal to one more formula 2 pi into f is nothing but frequency, it is nothing but time period of rotation. These are standard formulas. Now, after completion of this, suppose first object is moving in the anti-clockwise direction and another object is moving in the clockwise direction. So, we have the different direction of motions. One will be in this direction and another one is in this direction, clockwise and anti-clockwise. Then delta 1 2 is equal to, you can write down as opposite direction, I had to add the things, and 2 pi by t12 is equal to what you write down here, 2 pi by t1 plus 2 pi by t2 can write down, and relative frequencies are given by f12 is equal to, can write down as f1 plus f2 can write down simply. So how the frequency will be appeared for the another person during the rotation case. Okay, so like that you have to be take care for the different situations. Now let us enter into the next concept.